Good evening. Good evening.
हाँ, हाँ,
Good
विनीत।
evening.
गुड इवनिंग सर, नमस्ते।
Namaste. We'll wait maybe 5 minutes so others join and then we can start. Okay, let us start then. Is my screen visible to all of you? Is my screen visible?
Yes, sir, visible.
Okay, okay, good. So in this case, we are actually talking about gauge transformation, but the transformation that give rise to same physical same physical situation. That means, suppose we have a system S and we do some transformation and we get S prime. We have a system S and we do some transformation and we get the system to be S prime. Then, if S and S prime are physically same situation, then that kind of transformation is basically leads to symmetries. That kind of transformation basically leads to symmetries. Such example is, suppose you have a cylinder. Suppose you have a cylinder. Okay. Now this is the axis. If I rotate the cylinder by an angle, let's say 90 degree, but still I will not be distinguished unless I put a mark somewhere. ମୁଁ ଯଦି ଏଠି ଗୋଟେ ମାର୍କ ଟେ ଦେଇଥିବି ତାହେଲେ ମେ ବି ଜାଣିପାରିବି, ବଟ୍ ମୁଁ ଯଦି କିଛି ମାର୍କ ଦେଇନି, ମୋ ପାଖରେ ଗୋଟେ ନର୍ମାଲ ସିଲିଣ୍ଡର ଟେ ଅଛି, then it is difficult to know whether it is rotated or not. So before rotation and after rotation, the cylinder will look the same. So it has a axial rotation symmetry. So it is a axial rotation symmetry or cylindrical symmetry. So these kind of transformations, if we have a this kind of gauge transformations are basically referred as gauge symmetry. Gauge symmetry. Okay. So gauge transform. If I write gauge transformations leading to symmetries, then that kind of symmetry is called gauge symmetry. Okay. Now, let us try to see or examine what happens when all of you understand what we discussed in last class also, right? That what do you mean by gauge transformation? Gauge transformation means we are basically changing the potential by a constant number, by a constant potential, right? That's what we are doing. So now let us try to see what happens to Maxwell's equations. What happens to the Maxwell's equations when we have this kind of gauge transformation? So effect of gauge transformation on Maxwell's equation. Effect of gauge transformation on Maxwell's equation. Okay. The four Maxwell's equation. Let us try to see first the homogeneous Maxwell's equation. Homogeneous Maxwell's equation means what? Homogeneous Maxwell's equations. Maxwell's equation where there is no source term for the electromagnetic electric or magnetic field. Source term nothing. Electric field ର source कौन? What is the source of electric field?
Charge.
Charge. Well, we have discussed that source of electric field there are two. One is changing magnetic field, another is charge, right? Change in magnetic field will also create electric field. But if we see static source wise, then it is the uh, charge density which will create or charge which will create uh, electric field. So no charge density for electric field and no current density for the magnetic field. Okay. Now, what are those such kind of equations? One is del dot B is equal to 0. Another one is del cross E is equal to minus del B by del T. Isn't it? Hold on a second. Sorry. Now, with these two equations, let us look at few of the identities of vector calculus. Hmm? Identities of vector calculus. Called del dot del cross. If I take a vector x, what will be its value?
0. 0.
0, right? All of you remember this, right? From mathematical physics. You can always, if I just take 2 minutes to solve that, suppose your x vector is equal to x1 I cap plus x2 j cap plus x3 k cap. So then your del cross x is what? I cap, j
I
cap,
guess
k cap, del by
del
del
by del
x, del y, del by del z, then x1, x2, x3. All right. Okay. Now, what is the I cap component?
I cap whole into
Del x3 by del y minus del x2 by del z, right? Isn't it?
uh,
Then j cap component is del x2 by del x2 by del z minus, sorry,
del x3.
just, no, del x1 by del z minus del x3 by del x, right? Plus k cap. because I've taken a minus inside. So k cap del
Del
x2 by del x minus del
del y.
x1 by del y, right? Now if I try to take del dot del cross x, del cross x, so that means what?
I cap del by del x.
So that will be I cap del by del
Right.
x plus j cap del by del y plus k cap del by del z.
So,
Then dot product with this thing, right? Maybe I call it y dot y vector, isn't it? So that means I cap will be I cap will take a dot product with I cap, that will become 1. If I I cap dot product with j cap, that will be 0. I cap dot product with k cap will be 0, right?
del by del x.
So that will be equal to del by del x of
Del x2
del x3 by
del
del
y.
y minus del
Del
x2 by del z. Similarly, plus del by del y of
del
del
x1
x1 by del z
del
minus
x2
del
del x.
x3 by del x plus del by del z of del x2 by del x minus del x1, so del x1 by del y. Right.
Yes,
Now
sir.
considering that if we take derivative with respect to x first, y second is same as derivative with respect to y first, x second. Okay. If we have such kind of functions, then what will it be? First term would be what? Del square x3 by del x del y minus del square x2 by del x
Del
del
z.
z plus del square x1 by del y del z minus del square x3 by del y del x plus del square x2 by del z del x minus del square x1 by del z del y. These 6 terms we will get. Now look at this first term, del square x3 by del x del y. There is another term, del
Del
square x3 by del y del x. But as we say, ଆମେ ପ୍ରଥମେ with respect to x derivative ବାହାର କରିକି ତାପରେ with respect to y ବାହାର କରିବା ଯାହା
same হবো।
ପ୍ରଥମେ with respect to y ବାହାର କରି ତାପରେ x ବାହାର କରିବା ସେ okay. So then these two terms, because this is plus, this is minus, that will, they will cancel each other, isn't it? So similarly, del square x2 here, del x del z, del square x2 del z del x. So they will cancel each other. So finally, what you will get, this will be equal to 0, isn't it? So del dot del cross x is equal to 0. No, no. ଆମ ପାଖରେ ଇକ୍ୱେସନ କଣ ଅଛି? del dot b is equal to 0. ନା ନାଇଁ? ତା ମାନେ ଏ b ଟାକୁ b ଯୋଉ ଭେକ୍ଟର ଅଛି ତାକୁ ମୁଁ କଣ କରିପାରିବି?
Cross ଆକାରରେ
I can write in terms of sum. So I can write b vector will be equal to del cross of something. That something I call it a vector. बुझे होची तो एती कथा समस्ते
yes sir
यस जदि डेल डॉट बी 0 हैला ताले बी टा को मु डेफिनेटली डेल क्रॉस सम वेक्टर ए आकार रे लिखि परिबे एंड दिस ए इज कॉल्ड वेक्टर पोटेंशियल वेक्टर पोटेंशियल ओके ठीक अछि ना नेक्स्ट इज हमें कौन लिखिथिले सेकंड इक्वेशन था डेल क्रॉस ई इज इक्वल टू माइनस डेल बी बाय डेल टी isn't it एक कथा लिखथिलु ना
sir
सो माइनस डेल बाय डेल टी बी टा केते
del
डेल
cross A
क्रॉस ए नाउ डेल माने कौन व्हाट इज दिस डेल I cap del by del x, j cap
yes
del
sir
by del y, k cap del by del z. So that is derivative with respect to space or position, right?
yes sir
In front of it, derivative with respect to time. But position and time in non-relativistic formalism, position and time are mutually exclusive. They do not depend on each other, right? You cannot express time in terms of position, or you cannot express position in terms of time in non-relativistic mechanics, right?
0
So what we can do, we can take this del by del t here. So that's why I can write that will be equal to del cross minus del a by del t. All of you are understanding this one? Why
sir
I
why
am able to write it? Yes.
introduction କିଛି effect
हाँ,
ହେଲାନି
ଆମେ ୟା ପୂର୍ବରୁ ଯେତେବେଳେ କହିଲେ ଯେ ଡେରିଭେଟିଭ with respect to x ଆଗ କରିକି ତାପରେ with respect to y କରିବା ଯାହା ଡେରିଭେଟିଭ with respect to y କରିକି ତାପରେ x କରିବା ସେୟା ଏହା
ଆଜ୍ଞା
କହିଥିଲୁ ତ
ଆଜ୍ଞା
କେମିତି କହିପାରିଲେ ଆମେ ଏଇଥିପାଇଁ କହିପାରିଲେ କାରଣ ଯଦି ଗୋଟେ ଅବଜେକ୍ଟ ର x ଡିରେକ୍ସନ ରେ i କ୍ୟାପ୍ ଡିରେକ୍ସନ ରେ ଯୋଉ କ୍ୱାଣ୍ଟିଟି ଏକ୍ସପ୍ରେସ କରାଯାଉଥିବ ତାକୁ z ଡିରେକ୍ସନ ବା y ଡିରେକ୍ସନ ରେ ତାକୁ ଆମେ ଏକ୍ସପ୍ରେସ କରିପାରିବାନି ଦେ ଆର୍ ମ୍ୟୁଚୁଆଲି ପରପେଣ୍ଡିକୁଲାର ଟୁ ଇଚ୍ ଅଦର ରାଇଟ୍
ଆଜ୍ଞା
ସେଇଥିପାଇଁ ଆମେ with respect to x ଆଗ ନେଇକି ତାପରେ y କରିବା ଯାହା y ଆଗ କରିକି ତାପରେ x କରିବା ସେୟା ଠିକ ଅଛି ଏଠି କଣ କୁହାଯାଉଛି ଏ ଯୋଉ ଡେଲ ଅପରେଟର ଟା ନିଆଯାଇଛି କୋଉଟା ଡେଲ ଭେକ୍ଟର ଦିସ୍ ୱାନ୍
yes
so that one is what is that that is basically I cap del by del x plus j
position of
cap del by del y that is with respect to position and ଏଠି ଯୋଉଟା ରହିଛି ତା ଆଗରୁ del by del t that is with respect to time
time
so position and time they are mutually perpendicular or
exclusive
mutually independent right position cannot be expressed in terms of time and yes and time cannot be expressed in terms of position in non-relativistic when you go to relativistic mechanism then something changes things will change okay now if that is the case I can simply interchange ଆଗ with respect to x କରିକି ତାପରେ with respect to time କରିବା ଯାହା ଆଗ with respect to time କରିକି ତାପରେ with respect to x କରିବା ସେଇଆ so that is
ଏଇଟାକୁ
why
independent ଏଇଟାକୁ
yes
independent ଆମେ ଏକ୍ସଚେଞ୍ଜ କରିପାରିବା
yes so we can take it inside right so if that is the case so what I can do I can take this right side to the left side so it will be del cross e vector plus del a by del t right equal to 0 okay so what we get let me write down once again del cross E plus del A by del T is equal to 0. ଏଇଟା ଆମ ପାଖରେ ଆସିଲା ହେଲା now there is another vector identity କଣ ଅଛି del cross del psi is equal to 0 where psi is a scalar field or a scalar function. Psi is basically a scalar field. You can simply prove it. Maybe I'll take 2 minutes to show that. Del psi means what? I
I
cap
kept the
del psi by del x plus j cap del psi by del y plus k cap del z, right? Isn't it? Now
yes, sir.
del cross del psi means what? I cap j cap k cap del by del x del by del y del z. That is the I cap component del psi by del x, right? Del psi by del y del psi by del z. Can you try to find out what will it be? I cap del by del y of del psi by del z minus Am I audible? Am I audible?
Yes, sir.
Okay, there was some internet disconnection. I think. Okay, so, if you look at the I cap term, if you look at the I cap term over here, so what you will get? So, derivative with respect to z first, with respect to y second. Here, derivative with respect to y first, z second. But both are same, right? आगे with respect to y derivative नहीं कि तापर with respect to z derivative नबा जा आगे with respect to z नहीं कि तापर y नबा से या. So in that case, all the terms, sorry, this will be equal to I cap 0 plus j cap 0 plus k cap 0. So this implies what? Del cross del psi is equal to 0. ଆମେ ପାଇଥିଲୁ କଣ? Del cross E plus del A by del T is equal to 0. So this means this quantity within the bracket can be written in terms of del of something, isn't it?
Sir.
So let me write that. So E plus del A by del T is equal to minus del phi. I can introduce a minus sign. We'll see later why we introduced minus sign. Okay. ଏତିକି ପର୍ଯ୍ୟନ୍ତ ସମସ୍ତେ ବୁଝିପାରିଲ ତ?
Sir.
So this implies my E
Yes, sir.
vector can be written as minus del phi minus del A by del T. The phi is a, this phi is a
Scarlet.
scalar potential. This is a scalar potential and this quantity A over is a vector potential. Clear? All right.
Yes, sir.
Now electrostatic case where nothing changes with time, del A by del T becomes 0. So electrostatic case रे ଯେତେବେଳେ ଆମେ electrostatic କଥା କହୁଛୁ ସେତେବେଳେ electrostatic ମାନେ କଣ? Nothing changes with time, right? Time ସହିତ କିଛି variation ନାହିଁ. Only ଆମେ ଯେତେବେଳେ plus 2 level ରେ ପଢିଥିବ electrostatics କଥା ସେତେବେଳେ time variation କଥା କିଛି କୁହାଯାଏନି. ଖାଲି position ଟା change ହୁଏ. ଗୋଟେ ଚାର୍ଜ ଅଛି ତାଠୁ 5 ମିଟର ଦୂରରେ କେତେ ଇଲେକ୍ଟ୍ରିକ ଫିଲ୍ଡ ହବ? ଦିଟା ଚାର୍ଜ ଅଛି ତାଙ୍କ ମଝିରେ ଇଲେକ୍ଟ୍ରିକ ଫିଲ୍ଡ କେତେ ହବ? ଏଇଭଳିଆ ପଚରାଯାଏ. କିନ୍ତୁ ୱିଥ୍ ଟାଇମ୍ ଇଲେକ୍ଟ୍ରିକ ଫିଲ୍ଡ କୋଉ ଭଳିଆ ଚେଞ୍ଜ ହଉଛି ସେ କଥା ପଚରାଯାଏ ନାହିଁ. So that is why your del A by del T variation with respect to time ଯଦି କିଛି ନାହିଁ ତେଣୁ ସେଇ ଟର୍ମ ଟା କଣ ହେଇଯାଏ? ଜିରୋ ହେଇଯାଏ. ଠିକ ଅଛି? So ସେଥିପାଇଁ ଇଲେକ୍ଟ୍ରୋଷ୍ଟାଟିକ କେସ ରେ କଣ ଲେଖୁ ଆମେ? ଇଲେକ୍ଟ୍ରୋଷ୍ଟାଟିକ କେସ ରେ ଇଲେକ୍ଟ୍ରୋଷ୍ଟାଟିକ କେସ ରେ ଆମେ କଣ ଲେଖୁ? E vector is equal to minus del phi. ନା ନାଇଁ? ଏତିକି ଲେଖୁ. Now what happens to, let us try to see what happens to other two Maxwell's equations. Other two Maxwell's equations. कौन मैक्सवेल्स इक्वेशन अछि del dot E is equal to rho by epsilon naught, right? What is rho?
Charge density. Volume charge density.
Charge density. Charge density. Yes, volume charge density. Okay. Now substitute E ର value କେତେ ପାଇଛେ ଆମେ? This is the value of E, right? So if you substitute over here, what will you get? ସମସ୍ତେ ଟିକେ ଖାତାରେ କରୁଥିବ ନହେଲେ ନ କଲେ ମ୍ୟାଥମେଟିକ୍ସ ଟା ନ କଲେ ମାନେ ଫଲୋ କରିବାଟା ଡିଫିକଲ୍ଟ ହବ ହେଲା so that will be
Minus
del dot minus del phi minus del A by del T is equal to rho by epsilon naught. So this
Yes, sir.
implies minus del dot del square, right? Minus del square phi minus what will it be? Del dot del A by del T is equal to rho by epsilon naught. ଯଦି ମାଇନସ୍ ଟାକୁ ରାଇଟ୍ ସାଇଡ୍ କୁ ନେଇଯିବା କଣ ହବ del square phi plus okay now what I am doing I will be taking del by del T of del dot A ଏଭଳିଆ ଲେଖିପାରିବି टाइम ଆଉ position କୁ interchange କରିଦେଇ ପାରିବି
Again.
so that will be equal to
Minus
minus rho by
epsilon naught.
epsilon naught isn't it so similarly so this is one equation we are getting এটা କଣ ପାଇଲୁ ଆମେ ତା ମାନେ vector potential ଆଉ scalar potential କୋଉ ଭଳି ଭାବରେ ଚାର୍ଜ
Related.
ଡେନ୍ସିଟି ସହିତ ରିଲେଟେଡ ସେଇ କଥା ଆମେ ଇଲେକ୍ଟ୍ରିକ ଫିଲ୍ଡ କଥା କିଛି କହୁନୁ ମ୍ୟାଗ୍ନେଟିକ ଫିଲ୍ଡ କଥା କିଛି କହୁନୁ ଆମେ କହୁଛୁ ଭେକ୍ଟର ପୋଟେନସିଆଲ ଆଉ ସ୍କେଲାର ପୋଟେନସିଆଲ କେମିତିକା କାହା ସହିତ ରିଲେଟେଡ ଚାର୍ଜ ଡେନ୍ସିଟି ସହିତ ହେଲା ନେକ୍ସଟ we will see the other Maxwell's equation which is del just a second del cross B is equal to mu 0 J plus mu 0 epsilon 0 del E by del T. Okay, so that will be equal to mu 0 J plus mu 0 epsilon 0 del by del T of what? Minus del phi minus del A by del T. No, no.
Yes, sir.
Okay. What about B? B ର expression कौन थिला? Right hand side रे electric field नहीं, magnetic field नहीं. Left hand side रे magnetic field ଅଛି. तो ताकू कौन लिखिबा? del cross A. magnetic field को हमें del cross A କହିଥିଲୁ ନା?
Yes, sir.
मन पड़छि? ना नहीं. ଏଇଟା
Again.
magnetic field is equal to del cross A. ପାଇଥିଲୁ ଆମେ?
Again.
So if we come over here, that will be equal to mu 0 J plus mu 0 epsilon 0 del by del T of minus del phi minus del A by del T. Okay. Now what is del cross A? Eta kete?
Zero.
What is? No, not zero.
R plane.
Yes. Can some of you find out what is del cross A?
del cross A बाहर करियो
Hmm. କରୁନା ଟିକେ କରିକି କୁହ ସମସ୍ତେ ଟିକେ ଏଇଟା ମାନେ ସିମ୍ପଲ ମୁଁ ଦିଟା ଅଲରେଡି ଆଇଡେଣ୍ଟିଟି କହିଲିଣି
I can recap del by del x del by
yeah
del
so you calculate and tell me what is the end result all of you try to work it out this is what will be the value of this
सर a को ax ay az नहीं हुआ
हाँ a vector को तो मैं नहीं कि देखियो ना if you try to see a vector could be equal to ax I क्या
I can
ay j क्या az k क्या then try to find out what is the solution what is the value take 5 minutes and work out and tell me
ये cancel होना
ହଉଛି କେରା
सर किसी कैंसिल होनी
କ୍ୟାନସେଲ ହବନି
जीरो हो कि सर डेली हो डेली
ନା
एक्स
ନା
सर जीरो हो
ନା ନା ନା
कैंसिल कैंसिल କିଛି ହଉନି
କ୍ୟାନସେଲ ହବନି
लो जाई क्या फुल इनटू डेल
so
बाय डेल
del
ରହିବ
cross del cross a will be equal to
आई
del
क्या
del dot a minus del square a ଏତିକି ବାହାରୁଛି ଆଚ୍ଛା let us try to see the right hand side okay first ଆମେ right hand side ଟାକୁ ଦେଖିବା del dot sorry del del dot a ଏଇଆ ତ minus del square a ତାମାନେ କଣ this is equal to del by del x I cap del by del y j cap del by del z k cap operating on what del dot a so del ax by del x plus del ay by del y plus del az by del z এটা ଗୋଟେ part minus del square sorry del square means what del square by del x square plus del square by del y square plus del square by del z square operating on what ax I cap ay j cap plus az k cap this will be equal to ଆମେ ଯଦି ଅପରେଟ କରିବା ପ୍ରଥମେ କଣ ପାଇବା I cap component first term ର I cap component କଣ ପାଇବା del square ax by del x square first term plus del square ay by del x del y plus del square az by del x del z এটা ফার্স্ট টর্ম ର ফার্স্ট I cap ଟର୍ମ ସିମିଲାରଲି j cap ପାଇଁ କଣ ହେଇଯିବ del by del y so del square ax by del y del x okay plus del square ay by del y square plus del square az by del y del z ସେକେଣ୍ଡ ଟର୍ମ ତମେ ସେଠି ଲେଖୁଥିବ ଲେଖିଲେ ହିଁ ଜାଣିପାରିବ ନହେଲେ ଜାଣିପାରିବ k cap ଟା ସେଇଭଳିଆ କଣ ହବ del by del z so del square ax by del z del x plus del square ay by del z del y plus del square az by del z square ଏତିକି ମାଇନସ୍ ସେକେଣ୍ଡ ଟର୍ମଟା ଏଠି ଯୋଉ ସେକେଣ୍ଡ ଟର୍ମଟା ଅଛି ତାର ଯଦି ଆମେ ନବା ତାହେଲେ କଣ ହବ ମାଇନସ୍ I cap first I cap term so that will be equal to del square ax by
x square.
del x square. Okay, plus कौन होगा I cap term आउ कौन अछि?
Del square ax by del y square.
Yes, del square a x, sorry, just a second. Del square a y, del square a x. I'm writing wrong. Del square a x by del
Y square.
y square plus del square a x by del z square. Okay,
So,
same figure y j cap term कौन आसीबो? Del square a y by del x square plus del square a y by del y square plus del square a y by del z square minus k cap del square a z by del x square plus del square a z by del y square plus del square a z by del z square. Okay. Now look at ଏଠି ଗୋଟେ I cap del square ax by del x square ଅଛି. ଏଠି ଗୋଟେ minus I cap del square ax by del x square ଅଛି. ଅଛି ନା ନାଇଁ? ସେ କଟିଯିବ। ସେମିତିକା ଏଠି ଗୋଟେ del square ay by del y square ଅଛି। ଏଠି ମଧ୍ୟ ସେଇଭଳିଆ del square ay by del y square ଅଛି। ଥାର୍ଡ ସେମିତି del square az by del z square ଅଛି। ଏଠି ଗୋଟେ ପ୍ଲସ୍ ମାଇନସ୍ ହେଇକି କଟିଯିବ। ବାକି ତାହେଲେ ରହିଲା କେତେଟା? 1 2 3 4 5 6 7 8 9 10 11 12 ତମେ ଯୋଉ ଫାଷ୍ଟ ରୁ ବାହାର କରିଛ del cross a ସେଥିରେ ବି 12ଟା ଟର୍ମ ଆସିଥିବ ନିଶ୍ଚୟ
12ଟା ଆସିଛି ସାର୍।
ହେଲା you can check yourself ଯେ ସେଇ ଯୋଉ 12ଟା ଟର୍ମ ଆସିଛି ଆଉ ଏଠି ଯୋଉ 12ଟା ଟର୍ମ ବାହାରିଲା ସେମାନେ ସମାନ
ଆଜ୍ଞା।
okay so with that I can simply what I can write is ଏଇଟା ଟିକେ ମନେ ରଖିବ ଏ ଆଇଡେଣ୍ଟିଟି ଟା ବହୁତ ସମୟରେ ଦରକାର ହୁଏ so del cross a this is equal to del dot a minus del square a a is a vector ଠିକ ଅଛି
Yes,
ତେଣୁ
sir.
ଆକୁ ମୁଁ ବର୍ତ୍ତମାନ କଣ ଲେଖିଥିଲି କୋଉଠି ଲେଖିଥିଲି ଏଇ ଇକ୍ୱେସନରେ del cross a is equal to mu 0 j plus mu 0 epsilon naught del by del t of minus del phi minus del a by del t ସେଇଟାକୁ ଆଉ ଥରେ ଲେଖିବି ତାହେଲେ so I
Yes,
try
sir.
to write that what exactly I will write so del square a minus mu 0 epsilon 0 del square a by del t square minus del of del dot a plus mu 0 epsilon 0 del phi by del t this is equal to minus mu 0 j okay all right I'll stop it here let us go to the material where is it?
ଟିକେ ବ୍ୟାକ୍ କରିବେ
Yes.
ଟିକେ ଆନୋଟେସନ ସାର୍ ଟିକେ ଦେଖିଥାନ୍ତି ଲାଷ୍ଟ ମାଇନସ୍ ମ୍ୟୁଜିକ୍ ରହୁଛି ଓକେ ସାର୍
Okay. Just 1 second. Yeah, okay. So I suggest a page number 46. Page number 46 जो ଅଛି 46 and 47 ସମସ୍ତେ ଟିକେ ଆଉ ଥରେ ପଢିଦେବେ ହେଲା page number 46 ଆଉ 47 ଟିକେ ପଢିଦେବେ ତାପରେ ଆମେ ଦେଖିବା ଯେ ଭେକ୍ଟର ପୋଟେନ୍ ଯୋଉ ଗେଜ୍ ଟ୍ରାନ୍ସଫର୍ମେସନ କଲେ କଣ ହଉଛି ଏଇ ଯୋଉ ସ୍କାଲାର ପୋଟେନସିଆଲ ଆଉ ଭେକ୍ଟର ପୋଟେନସିଆଲ ଇକ୍ୱେସନ ଗୁଡା ହେଲା so at this point I'll take a break and during that break just go through this two pages and then if you have any doubt we can discuss. I'll take a 10 minutes break and then I'll start. Okay, ସମସ୍ତେ ଟିକେ ଦି ପେଜ ପଢି ଦିଅନ୍ତୁ ସେଇ ଟାଇମ ଭିତରେ ହେଲା ସମସ୍ତଙ୍କ ପାଖରେ PDF ଅଛି ତ
ସାର୍
yes just go through it page number 46 and 47 if you have any doubt you can ask me. Okay, we'll start after 10 minutes.
Did you go through the text? Is it okay? Are you able to understand?
Yes, sir. ବୁଝିଲା sir.
Okay. Just 1 second. My audio is somewhat. Maybe I'll just log out and log in again.
Yeah, I'm audible, right?
Yes, sir.
Okay, good, good. ବୁଝିହେଲା ସବୁ ପଢିଲ?
Yes, sir. ବୁଝିଲା sir. ଆମେ ସେ ଇକ୍ୱେସନ ଟାକୁ କ'ଣ କହିବା? ସେଟା ଲରେନ୍ସ ଇକ୍ୱେସନ। Transpiration of
We'll
Maxwell
come to
equation.
the transformation of Maxwell's equation. We'll come to Lorentz equation. Wait. ବର୍ତ୍ତମାନ କଥା ହେଲା ଯେ ଆମେ ଏଇ ଯୋଉ ଲେଖି ପକେଇଲୁ ଦିଟା କଥା. So we wrote two things. One over here, if you look at it, that B is equal to del cross. Just a second.
A.
Yeah. So B is equal to del cross A. But is this A unique? Is this A unique? Similarly, we wrote over here that E plus del A by del T is equal to del phi. Is phi unique? All right. So that thing we have to think about. ଆଉ ଆମେ ଯୋଉ equation ପାଇଲେ ବର୍ତ୍ତମାନ involving rho and J, charge density and current density, this looks little bit complicated. It's not very straightforward equation, isn't it? So the question now is, can we simplify it? Can we do little bit of simplification? Okay.
Sir, unique means B is equal to del cross A.
Yeah,
You put it-
that's what let me write it down. Huh? Let me write it down. So then it will be clear. Okay. So suppose what we wrote is B is equal to del cross A, isn't it? B is equal to
del
del
cross.
A. Let A prime is equal to A vector plus some gradient of a scalar function chi. I choose A prime in such a way that A vector is equal, A prime is equal to A vector plus gradient of a scalar function chi. This is a scalar function, arbitrary scalar function. Okay. Now what is del cross A prime? Del cross A prime. What will it be? Sorry. This will be equal to del cross A prime ta kete ki? A plus del chi. I have chosen, right? So that will be equal to del cross A plus del cross del chi. What is this? 0, right? Isn't it? I will just prove କରିଥିଲୁ ନା? Curl of gradient is 0, right? We have
Yes, sir.
proved.
Yes, sir.
So if this goes to 0, this is equal to डेल क्रॉस ए तो मैंने कौन मिलला डेल क्रॉस ए और डेल क्रॉस ए प्राइम दिटा को समान आ जदि मु b इज इक्वल टू डेल क्रॉस ए लिखि पारुची ताले मु b इज इक्वल टू डेल क्रॉस ए प्राइम भी लिखि परिबे ना लिखि परिबे
Yes, sir.
बट a and a prime are not same, right?
Yes, sir.
So a prime can always be written as a plus some gradient of a scalar function.
Yes, sir.
जदि गोटे मात्र a ପାଇଁ ହେଇଥାନ୍ତା ଆଉ a prime ପାଇଁ ହେଇ नथान्ता ताहाले ठीक अछि ताले हम कहथान्ते यूनिक way to express it हैला
Yes, sir.
but that is not the case, it is not unique. So a prime obtained by adding gradient of an arbitrary scalar field to the vector potential for magnetic field is also a vector potential. So this shows a change in A can cause change in electric field. Electric field टा केते की हमें पूरा एक्सप्रेस करथिलु minus del phi minus del A by del T ये କଥା हमें लिखिछु ना electric field is equal to minus del phi minus del A by del T मैंने जदि हमें A टा को चेंज कर दोचे A प्राइम कर दोचे ताले मैग्नेटिक फील्ड रे किसी चेंज हबार नहीं nothing will change in the magnetic field
Yes, sir.
but electric field will change, right? Isn't it? Electric field with A prime लिखिबी E is equal to minus del phi minus del A prime by del T. A prime टा केते A prime टा पूरा A plus del chi, so minus del phi minus del by del T A vector plus del chi. This is equal to minus del phi minus del A by del T, then minus del by del T of del chi. এটা extra term টা আসলে না নাই electric field will change, isn't it? So in order that the electric but যদি magnetic field change হউনি তাহলে electric field change হবার কথা নয় কারণ আমি সেই ম্যাক্সওয়েলস ইকুয়েশন তো সেটা পড়িলু না যে change in magnetic field will create electric field and change in electric field will create magnetic field. But যদি magnetic field টা change হউনি ଆଉ ଆମେ ମ୍ୟାଥମେଟିକ୍ସ ରେ ଦେଖୁଛୁ ଯେ ଇଲେକ୍ଟ୍ରିକ ଫିଲ୍ଡ ଟା ଚେଞ୍ଜ ହେଇଯାଉଛି ତାହେଲେ କଣ ହବ ଦ୍ୟାଟ୍ ମିନ୍ସ ହ୍ୱାଟ ଏ ଯୋଉ ଟ୍ରାନ୍ସଫର୍ମେସନ ହେଲା ବେଳକୁ
Not
ପୋଟେନସିଆଲ ଟା
symmetric,
ବି ସେଇ ଭଳିଆ ଚେଞ୍ଜ ହବା ଦରକାର ପୋଟେନସିଆଲ ଟା ବି ସେଇ ଭଳିଆ ଚେଞ୍ଜ ହବା ଦରକାର ତେଣୁ ଏଇ ଟର୍ମ ଟା ମୁଁ କଣ କରିବି I'll introduce over here so I can write minus del phi minus del A by del T minus del of del chi by del T. Okay? Nani?
Yes, sir.
So I have to include this part over here. ସେଥିପାଇଁ ସେ ଗୋଟେ ଏକ୍ସପ୍ରେସନ ତମକୁ ନେଇଛି ଯେ ଯଦି phi prime ଟା ଗୋଟେ phi prime define କରାଯିବ phi minus del chi by del T ତାହେଲେ ଯାଇକିରି ମ୍ୟାଗ୍ନେଟିକ ଫିଲ୍ଡ ଟା ଅନଚେଞ୍ଜଡ ରହିବ ତେଣୁ ଆମେ ଆମର ମେନ୍ କାମ ହଉଛି ଯେ ଇଲେକ୍ଟ୍ରିକ ଫିଲ୍ଡ ଏକ୍ସପ୍ରେସଡ ଏଜ ଇଲେକ୍ଟ୍ରିକ ଫିଲ୍ଡ ମୁଁ ଆଉ ଥରେ ସେଟା ଟିକେ ଲେଖି ରଖେ electric field expressed as minus of del phi minus del A by del T. ଯଦି E prime ଲେଖିବି, that will be equal to minus del phi prime minus del A prime by del T. Now, E and E prime must be same. Must be same. তাহলে কোন হবে? The minus del phi prime minus del A prime by del T must be equal to minus del phi minus del A by del T. যদি মোর if my A prime is equal to A plus লিখলো তো A plus del chi A plus del chi, then I have to have phi prime. I have to have phi prime is equal to phi minus del chi by del T. मते एई भलिया जदि मु वेक्टर पोटेंशियल को चेंज कली ताहले टू कीप my electric field and magnetic field same, I have to change my scalar potential as well. तो सर एमती कोन मन इच्छा वेक्टर पोटेंशियल स्केलर पोटेंशियल चेंज कर दे परिबे ना गेज ट्रांसफॉर्मेशन कहउची हम गोटे कांस्टेंट क्वांटिटी रे चेंज कर दे परिबे तो कांस्टेंट क्वांटिटी जदि थिबो ताकू हम चेंज करि परिबे माने कांस्टेंट we can level increase the potential or decrease the potential by a constant quantity so that the field will not change. Field will not change means the dynamics will not change. So simultaneous transformation of vector potential and scalar potential leave the electric field and magnetic field invariant. Okay. अच्छा आपको बुझिबा पई let us come to the material. Can all of you go through this example 2.1? I'm बुझी पारछो कि नहीं मते ଟିକେ କହିଲ देखि ये जो example 2.1 देछि is a very nice example. जे gas transformation हेले find a gas transformation that will transform the scalar potential to 0 and determine the transform vector potential under this gas transformation. Gas transformation is such transformation which will not change the electric field or the magnetic field, but it will change the scalar potential and vector potential. काहेकि चेंज आमे देखिलु जे स्केलर पोटेंशियल और वेक्टर पोटेंशियल गुडा यूनिक नुहंती तांको देरे तांको जदि आमे ଗୋଟେ कांस्टेंट क्वांटिटी रे चेंज करबा ताहले बोथ को जदि आमे वेक्टर पोटेंशियल को चेंज करछे ताहले हमको स्केलर पोटेंशियल भी चेंज करिया पई पड़िबो टू कीप आवर इलेक्ट्रिक एंड मैग्नेटिक फील्ड सेम. All of you just go through, take 5 minutes, go through example 2.1, else I will explain. This is a very nice example. बुझी होची एग्जांपल 2.1 all of you be able to understand or not?
Sir, it is integrating the last equality, then we get ସେଇଟା କେମିତି ଆସିଲା ତା ପର equation?
Okay, let me explain. Hala. Starting with कौन ଦେଇଛି क्वेश्चन रे से कहूची जे गोटे स्केलर पोटेंशियल वेक्टर पोटेंशियल दिटा ଦେଇଛି राइट
हाँ सर
स्केलर पोटेंशियल phi is equal to केते गोटे सिंगल चार्ज ଦେଇଛି phi तेणु 1/4 pi epsilon naught
Q by R.
q by r
R.
ଆଉ a ଟା ଦେଇଛି केते this is equal to 0
0.
obviously phi is a function of r and t a is also a function of r and
T.
right
Yes sir.
से कहूची make make gauge transformation such that your phi becomes 0. Phi becomes 0 means phi prime. Change color.
Yes.
Phi prime becomes 0. Then phi prime is equal 0 and a prime पे भी change है Then find corresponding a prime. बुझियला क्वेश्चन बुझियला
Yes sir.
ओके वर्तमान आमे जो इक्वेशन या आगरु लिखिथिलु कोन लिखिथिलु जे a प्राइम इज इक्वल टू a प्लस डेल काय
Chi.
जदि एमिति हैला ताले phi प्राइम ता केते हबो phi माइनस डेल काय बाय डेल t
T.
ना नहीं
Yes sir.
माइनस नहीं है लगता
yes
माइनस नहीं है डेल
no we have chosen it like that we have chosen it like that okay
ओके
Okay.
now given phi is equal to 1/4 pi epsilon naught q by r and phi prime is equal to 0 right ताले ये जो इक्वेशन अछि इक्वेशन 1 और इक्वेशन 2 ताकू हमें यूज करबा अच्छा इक्वेशन 2 रे phi prime is equal to 0 so 0 is equal to 1/4 pi epsilon naught q by r minus del chi by del t ना नहीं
Yes.
this implies del chi by del t is equal to how much 1/4 pi epsilon naught q by r del by del t आकु काईटा ताली पाइबे केमति ए जो काईटा को हमें केमति पाइबा
इंटीग्रेशन करिए
ताले दी साइड को इंटीग्रेट करबा विथ रिस्पेक्ट टू टाइम
Time.
देखो काईटा गोटे फंक्शन ऑफ कोन खाली टाइम नो काई इज नॉट अ फंक्शन ऑफ ओनली टाइम इट विल आल्सो बी अ फंक्शन ऑफ पोजीशन तेणु सेठी में डेल बाय डेल टी कहछि माने सेथरे पोजीशन पार्ट रे कोनसी डेरिवेटिव निया हैनी ओनली टाइम पार्ट रे निया हैछि तो हमें जते बे इंटीग्रेट करिबा राइट हैंड साइड को सेथरे कोन आसीबो 1/4 पाई एप्सिलॉन नॉट q by r into t प्लस गोटे कांस्टेंट आसीबो प्लस गोटे
ठीक
कांस्टेंट गोटे constant ଆସିବ integration constant ନା ନାଇଁ?
Yes, sir.
But this integration constant will be a function of position. But it will be independent. It will be a constant for time, but it will not be a constant for position. It will be a function of position. So that is why it will be written as f of r. Where f of r is any arbitrary function of position. It could be any function of position only. There will not be any time. Okay. So if that is the case, then this implies a prime is equal to a plus what? Del chi.
Kai.
But a ଟା କେତେ କୁହାଯାଇଥିଲା? a ଟା କେତେ ଥିଲା? 0, right?
Zero.
a 0 ଥିଲା ନା ନାଇଁ?
Yes.
ତାହେଲେ del chi କେତେ ହବ ତାହେଲେ? del chi ଟା କେତେ?
A
1
prime.
by 4 pi epsilon naught qt by r, right? Plus del
F of r.
f of r. Now, mathematical physics रे तमे पढ़िଛ जे एई जो डेल ऑपरेटर को हमें आई कैप जे कैप के कैप रे एक्सप्रेस करि परिबा ता छोड़ा r theta phi रे भी एक्सप्रेस करि परिबा. We can also express in terms of r theta phi, r cap, theta cap, phi cap, right?
Yes, sir.
वर्तमान एई जो ब्रैकेट भितरे जो टर्म ता अछि, it is only a function of r. There is no theta or phi dependence. So that is why I can simply take this del to be equal to del by del r of 1 by 4 pi epsilon naught qt by r plus del fr. Obviously here I will put r cap because del by del r cap, then 1 by r del by del theta theta cap এই ভলিয়া আছে না নাই?
Yes, sir.
So for that, since it is theta and phi dependence nahi, so del by del theta by del phi kole so zero asibo. So for that reason I can only take del by del r. So the del by del r nebi তাহলে এটা কেতে হয়ে যাব 1 by 4 pi epsilon naught q t by r square, but then 1 over r square, so there will be a minus sign, r cap plus del f of r. ବୁଝିହେଲା ନା ନାଇଁ?
So minus sign ଟା କେମିତି ଆସିଲା?
1 by r ର derivative କେତେ କି? If I take del by del r of 1 by r, it will be minus
Yes,
1 by
1 by r square.
r square.
Yes, sir. Yes.
Got the point?
Yes, sir.
ତେଣୁ କଥା ହେଉଛି ଆମେ ଆମର main part ହେଉଛି the dynamics should not change. That means electric field and magnetic field should not change. But without changing electric and magnetic field, we can simultaneously, mark the word simultaneously, we can simultaneously change the scalar potential and vector potential. Okay. Once you understand gauge transformation, then Lorentz gauge and Coulomb gauge are special cases. For example, let us come to the material. As a Coulomb gauge. Coulomb gauge we कौन कौची? In this gauge, the condition imposed on vector potential is del dot A is equal to 0. से कौची हमें एमिति गोटे vector potential नभा ଯାହାର del dot A 0 होतो ताकू ही हमें Coulomb gauge कहरा. We can हमें प्रथम रो discuss करलु जे we can choose vector potential according to our wish. It is not unique, right? It is not a unique vector. A prime can always be written as A plus gradient of some function chi. So for that reason, so Coulomb gauge will be the condition del dot A is equal to 0. So similarly, if we take Lorentz gauge, in Lorentz gauge, both scalar potential and vector potential satisfy the inhomogeneous wave equation. So what is the condition imposed? That mu 0 epsilon 0 del phi by del t plus del dot A is equal to 0. আমি जो equation गुड़े लिखी थिले, come back to that equation. हाँ. If you try to see, just a second, just 1 second. Mu 0 epsilon 0 del phi by del t plus del dot A is equal to 0. এই টার্মটা মার্ক করতে and then come to this one over here. Is it the same term? Del dot A, del dot A, mu 0 epsilon 0 del phi by del t is equal to 0. That is the condition. ଆମେ जो equation ଲେଖିଥିଲେ ବୁଝି ହଉଛି ନା ନାହିଁ?
Yes, sir.
So ଆମେ ଗୋଟେ condition ଏଠି impose କରିଦେବା, this is equal to 0. Yes. Okay.
Okay.
So I will stop it here. All of you go through this gauge transformation in general. Then maybe we can discuss Coulomb gauge and Lorentz gauge in specific and what are their uses. Whether Coulomb gauge should be used or Lorentz gauge should be used, and what consequences we will see in the next part. But I suggest all of you go through this gauge transformation and the mathematics involved in that. Okay. Any question? Whatever is discussed.
Good night.
Okay. If no question, then I'll stop it here. Thank you for your listening.
Thank you, sir.